Hello and welcome to Hearing Your Future, the Coding Your Future podcast. My name is Duncan and I'm on a mission to help you design, build, test and code your future in computing. In this podcast we'll talk to current and former students of computer science to find out more about their journey from student to professional. What's their story? How are they coding their future? What advice would they offer their former selves and fellow students, and where are they headed next? My guest today is Raluca, who graduated with a Bachelor of Science degree in Human-Computer Interaction back in 2020 when this episode was first recorded. So thank you for agreeing to talk today. I suppose today I wanted to find out a little bit more about your story and your journey from arriving here 4 years ago. Is that right? 3.5 years ago?
Thank you for inviting me. Yeah.
I suppose it's 3.5 years now, isn't it?
It was almost 4 years now.
4 years, getting on for 4 years.
Yeah.
It's time flies by, doesn't it? It's incredible. So the first question is for people who are listening to this is, can you tell us a little bit about yourself, your name and where you're from?
Yeah, of course. My name is Raluca Cruceru. I am 22 years old and originally from Romania. And I came to the University of Manchester to study computer science. And here I am now in my final year.
4 years later, about to graduate and go off into the big wide world.
Yes.
I think it's always interesting hearing what made people study computer science. So what was it that made you 4 years ago think, well, probably more than 4 years ago now, while you were doing your exams, applying to Manchester, and why did you choose to study computer science as a subject? So not why Manchester necessarily, but why computer science?
Well, I think that everything I experienced before university connected together into my final decision. When I was a child, I was always interested into how computers work or what they work as they work. But of course, at the time, everything was blurry. But then in high school, it became more clear that I'm attracted to this idea of technology and computers. My class was focused on mathematics and informatics. So therefore, I was always into this kind of information. And the solving problems became natural for me. I could spend hours doing that. So at the end of the high school, it was obvious that I wanted to do something concerning computer science or mathematics. And it was a decision between mathematics and computer science. And
Right.
I chose computer science because it felt like something that could be used in more circumstances, in more industries, and more linked with the general technology.
Yeah.
So, it's kind of went like this.
So you must have done a fair amount of computer science at high school. Did you do much in the way of coding in high school, or was it more focused on the mathematics?
It was focused on the mathematics, but then we also started to code in high school. And I think this is actually what helped me a lot to realize that I wanted to do computer science. Also, one of my exams that I chose at the end of my high school was for informatics. So I kind of fell in love with this idea. So yeah.
Yeah, and then it was, I suppose, a fairly easy choice in that sense, because I know some people have terrible dilemmas as to whether they should study this or this, and sometimes their options are quite different. But computer science and mathematics are fairly close.
Yes, exactly.
And I guess you did.
And even so, I was confused, but
yeah. Did you study any mathematics other than the basic that you need to do for the computer science degree? Did you do any external modules from maths while you were studying?
In high school or in university?
Oh, so in university, did you do any from the maths department as an option?
No, unfortunately, I couldn't do that because my degree is computer science, human-computer interaction.
Right.
And
yes.
Yeah, so in my degree, we did not have a mathematics course units, unfortunately, because I liked the maths. But it went.
Yeah. Okay, good. So fast forward then. So you've done your first year of your undergraduate degree, which is common to all the different degree programs. And then you had to start making choices about whether to do a year in industry or not. So how did you go about deciding whether that was something that you wanted to do?
Well, initially I didn't know about this option to have 1 year experience in industry, but when I found about it, I was very excited because I think for myself, the hands-on experience is very important. And of course, we needed all the theory behind and all the lessons, but I really wanted to understand what software engineering job actually requires. So as soon as I found out about this option, I was more than ready to take it.
Yeah.
And so I started to search for possibilities.
So there's typically most people are looking for placement start at the beginning of their second year, so after they've done the first year. So what sort of places did you apply to, and were you looking at lots of different things, or were you focused in on one or two places?
Well, to be honest, I was very focused on CERN because I knew I wanted to work there. However, I was very doubtful regarding my chances. So there was not my only option. I applied to other companies in the UK, for example, Data Stacks or Web Applications UK. And at the end, I got offers from them as well. But let's just say my heart was still bound to CERN. And of course, I was lucky in the end to be accepted there.
I think, did you do a summer internship at the end of your first year? Is that right from memory?
Yes, I did. Yeah. I did a summer internship at Web Applications UK in Holland.
Right.
That was my first experience.
Sometimes that then helps then when you're applying for placements, if you've got summer internship experience. It's a bit of a chicken and egg situation. You can't get a job until you've got some experience, but you can't get some experience without getting a job. So it's a cruel dilemma, I think, not dilemma, the cruel thing sometimes to students, where very competitive places like CERN will expect you to have, or your application will stand out a lot more if you've got some experience like you had. So you've done a summer at Web Applications UK, which is now called, they've changed their name now to...
Yeah, it's called Koderly now.
Koderly with a K.
Yeah.
So you got a sort of broader exposure to different sort of software engineering ideas, I guess, working in a team and that kind of stuff.
Yeah, it really meant a lot because it's one thing to work on a lab at university and another thing to work on something that can impact a whole number of people. So it makes you want to do a good job.
You know that the stuff that you're writing is going to be used by hundreds, sometimes thousands of people. I think that's one of the satisfying things about software engineering, is knowing that what you've made can end up getting used by lots of people, but stressful as well.
It's both stressful and exciting, in my opinion.
Right. Yeah, there's lots of places it can go wrong, isn't there? I think when you're building software. Okay, good. So I think for CERN, you mentioned you're particularly focused on CERN. I think they have 2 application rounds. Is that right? So you applied in the autumn?
No, actually, I applied in the second one from May onwards.
All right. So you didn't apply in the first round in autumn?
Yeah.
No,
I applied in the second one. Yes.
In the second round in May. Yeah. And so I mean, I guess lots of people have heard a lot about CERN, but can you tell us more about CERN as an organization and what your role was while you were a technical student there for a year?
Yeah, sure. So CERN is the European Organization for Nuclear Research in Switzerland, and their main focus is on high energy physics research. They operate the largest particle physics laboratory in the world. And the main focus is to unravel the mysteries of the universe, more specifically how it was formed, and from there to understand how it will evolve in the future. And the thing that attracted me the most was the fact that they push the frontiers of not only science, but technology, computing, and also medical technology. And maybe a lot of people know that the World Wide Web was created there in 1989. And yeah, it's interesting to know that I was a student at the university where we had the first piece of software held on a computer, and then go to an organization that created the World Wide Web. It's like everything is connected. And of course, I knew about CERN since I was a child, but I didn't really imagine that I would actually work there. It was just like something to dream about when you go to sleep. But yeah, in the end I got accepted, and I worked as a software engineer in the electrical engineering department. Basically, my task included building and maintaining software applications for the department, um, for monitoring projects of cabling and fiber optics there. And I had several tasks to do, building technical panels that would extract and migrate the information from different databases regarding these projects. Then a dashboard that was monitoring the projects, their evolution, and generating statistics regarding the quantities of cables or the radiation dose intake. And then after that, those statistics were published on the department website, which I also maintained. So as you can see, there were a lot of tasks, and I learned very much how to be able to handle multitasking at that time.
Yeah. The thing that I think is perhaps most surprising about CERN is the fact that for every scientist they employ, there are 10 engineers, and an awful lot of those engineers are software engineers, but you've also got the hardware and electrical engineering as well.
Yes.
So there's an awful lot of engineering that goes on. I mean, it's a big machine underground, basically, isn't it? At the end of the day,
Exactly.
And machines need lots of engineers, so there's lots of stuff. But I guess it was nice being part of a international community while you were there, because you're meeting people from literally all over the world. I mean, principally Europe, but you get people from all over, don't you? And all students and staff coming together.
Exactly. And the community they created there, it's so beautiful. There are scientists and engineers from around the world. And the atmosphere is just great. You feel like everybody has the same purpose, and we have something to collaborate for and something to work on together. It just brings people together from different domains, which is great.
Yeah. So, so when you applied to CERN, what was your strategy? Because I know you have to write sort of a personal statement type thing where you describe your interests. So were there any things that you emphasized? Did you particularly tailor what you'd written to particular groups? Because there's lots of different groups at CERN doing software engineering. It's not just one. Did you tailor it at all? Was there anything that how did you go about applying?
Well, the thing that I knew was that when you apply, there's not a specific department you apply to. So you apply and then you are sent to a specific group. But I spent a lot of time in trying to make my application having a personal touch. I was as honest as possible about why I wanted to work at CERN, about what impressed me, why I respect what they do. And of course, I try to talk enough and a lot about what makes me be a good candidate for them.
Yeah.
So I think in general, I think when applying, people should put a lot of focus on details. Even if you think that something is not relevant to put the accent on, it can be actually something that makes you stand out. And even at that time, I was not sure I would be accepted. Even with all this effort, I was still doubtful.
And I mean, it takes quite a lot of time to do it as well. So every application, and particularly a CERN application, takes a long time you have to think quite hard about what you're being asked and what you're going to say. And you never know if any of this is going to come to anything. It can be quite demoralizing, I think, sometimes filling in all these forms and writing all these personal statements when you never actually know if you'll get a reply.
Yeah, because they ask you not only about what you can do, but more questions to see what kind of person you are and what do you want to bring into the department you will work in.
Yeah.
So that's why you have to pay a lot of attention.
Yeah. So you were at CERN for, was it 12 months or were you there for slightly longer? Did you extend over the summer?
Yes, it was initially 1 year, but then I had the contract extension with 3 more months. And when they proposed that to me, I was more than happy to accept it. But then, of course, I had to confirm it with the university, and luckily it was accepted.
Yeah. Did you learn any French when you were? I mean, did you speak any French when you were out there, or was it mostly in English that you were speaking?
People speak mostly in English, but also in French, and we had French courses when we went for the first time there. So all the beginners could choose to have a French course for a couple of months. So I learned a little bit. I cannot say I learned a lot, and if they speak to me slow enough, I can communicate. But then when they start to talk faster, it's a bit difficult for me. So I switch back to English as fast as I can.
And you were living in France or in
France.
Geneva, in France.
I
So
lived in France, yes.
because it's
Because
close to the border, isn't it, of France?
exactly. Yeah, it's very close, and the border is open, so you can just pass and go to
Yeah.
CERN.
So did you spend any time exploring around Geneva and the part of France that you're in, or did you have any chance to see the country while you were there?
Yeah, I visited a couple of cities in Switzerland. I was in Zurich, in Bern, and I think from Switzerland, Bern is my favorite city. It's a small city, but it's very beautiful.
Yeah.
And I think if somebody has the chance to go to CERN, there are a lot of things to do and to visit. You can just go hiking when you feel bored because the nature is amazing around there.
Yeah.
There's
And
always something to do.
do you ski or snowboard at all? Is that something you're a winter sports person as well, or are you?
Honestly, there's a skiing club at CERN, but I didn't go last year. But now I will try to go as soon as I get the chance. Because at the beginning I'm not a very winter sport person, but now I'm going to push myself because it seems very, very fun.
Yeah. I mean, it can be quite an expensive sport, but when you're living close to the mountains, it becomes a lot more affordable because it's only a 30-minute drive away or whatever it is. Whereas not normally it involves hiring an expensive chalet and all that stuff. But I think when you're living in the country, it's a good thing to do. Okay, good. So you came back from it would have been 15 months, I suppose, at CERN into your final year. So actually, before I move on to that, actually, so what would you say was the most enjoyable or rewarding part of the placement? And you mentioned that you're part of this international community and learning heaps of stuff. Is there anything that really stands out for you from what you got from your year at CERN?
Yeah, so first, of course, is the whole community that I found there. So I just felt like my place was exactly that. But I think one of the most important things is that I learned how to multitask a lot, how to be able to learn new things. Because I think a couple of years ago, I thought that, okay, if you feel like you cannot learn this specific skill, you will never learn it. But then in the end at CERN, there were so many things I had to learn that I didn't even have time to worry about not being able to. And so in the end, I learned details that I never thought I would understand. Also, not in my area of expertise. For example, details regarding cables or fiber optics, I never got in contact with that before.
Yeah.
And also, it was my first experience seeing how what you're doing is actually used and has impact on people. And it gave me this sense of purpose because I had full responsibility over my tasks as I was there, and it made me even more excited to do a good job.
Yeah.
I think those was the more important things I enjoyed there.
Good. Okay. So you came back from your year at CERN, or just over a year at CERN last September, and came into your final year. So what were you doing for your final year project? Can you tell us a little bit more about what you did for your final year project?
Yes, I was working on a project related to neuromorphic computing, which is concentrating on building computer architectures that simulate the working and the structure of the human brain. And I worked on Spinnaker, which is the computer built at our university. The idea behind it is to implement spiking neural networks, which are artificial neural networks that have computational elements that mimic real neurons. And my job was to build a new neural model to implement into Spinnaker, and to be able to see if it provides the right behavior that we were expecting. And I was lucky that I worked a lot for it, and in the end it was working. And that I saw how complex and how complicated it is to build even one neuron. So I imagine how complicated it is to build another a full network of neurons. And the reason I chose this project is I believe this area of research is very interesting. Being able to simulate the real brain will not only bring progress into computer science, but also in neuroscience, for example, just a platform for neuroscientists to analyze the brain and see how it works or how diseases are formed. Yeah, it was a great journey for me this year.
Yeah, so that's part of the Human Brain Project, isn't it?
Exactly.
It always amazes me the size and complexity of the human brain is, far beyond what we can currently even begin to simulate.
Exactly.
I think I forget the figures, but how many mice brains is a Spinnaker now up to?
How many
mice? So you can simulate the brain.
I know for sure that it can simulate a full rat cortex at the moment.
Right.
This is what I know cortex. For sure to tell.
Yeah.
But other than that, I can see that it's evolving pretty fast. So who knows? Let's see.
And that's a lot of silicon, isn't it? It's how many processors does one of those? How many processors do you have on Spinnaker at the moment? How many cores?
I don't know for sure how many they are, to be honest.
So I think, was it last year or the year before, they passed the 1 million core? So
I think
1 million cores, which is an insane amount of
it's
power.
Unbelievable.
But it can you say all that power, you can only simulate a rat cortex, the brain of a rat, and you use a huge amount of power, and your brain, the brain inside your head, does that on something like about 40 watts or something. It's a much lower. It's amazing that it works at all, frankly.
Yeah, and with all the speed and the learning progress of the brain, I think it's not even fully understood by neuroscientists.
No.
So simulating it's then even harder because it's not fully understood.
Yeah. So your supervisor for that was
David Lester.
David Lester, right? Okay, good. So so the next thing then is there's two things really. Your plans for the future. So I know that CERN's actually unusual in that a lot of students who go to CERN aren't recruited so that they can go back after they have done their placement. And a lot of placement students go back to their employer after they graduate. But with a lot of CERN students, that's not the case, because they have this educational thing where the money that they're getting from the European member states, a sort of condition of getting that money is that they educate and train people all over Europe. So it's not just about recruiting lots of engineers doing a placement there. It's about spreading the knowledge of all the technology and systems and know-how that is at CERN, spreading that around as widely as possible around Europe.
Exactly.
I understand in your case you are actually planning to go back. I think you might be the first University of Manchester student to go back, other than do you know Josh?
Yes.
Josh Dawes went back there to do a PhD. But there aren't so many students who go back, not because it's not a nice place to work, it's just because the way that the technical studentships are set up is to encourage people to learn some stuff and then move on to somewhere else. So your plans for the future are to go back to CERN, is that right?
Yeah, so luckily for me, I was offered a graduate position at CERN in the experimental physics department on a major experiment that they have there. So
it's a different group to what you're working on before?
Yes, it's the experimental physics department, and it's an ALIX experiment, which I can talk a little bit about if you want. Yeah.
Right. So that'll be another adventure then, I guess, in terms of the stuff that you're going to be learning. Do you know too much yet about the group or what they're doing? Is it?
Yeah, I already know something because I wanted to get into that position. I knew about it, but of course I was not sure I would be accepted. And ALICE, or it's called a Large Ion Collider experiment. It's one of the experiments at CERN where they study the properties of strongly interacting matter at extreme densities and temperatures, the collisions in the accelerator. And I will be working on a technology for organized distributed data analysis. that is dedicated to storing and accessing the physics data output from Alice.
Right.
So yeah, and this is very important for the Alice physics output to be able to be accessed by scientists and analyzed.
Mm. So the graduate program at CERN, is it called a graduate program, or do they call it a scholarship, or what?
This is a fellowship. A
fellowship. Okay.
Yeah.
And how long is the fellowship for? Is it for a fixed term?
It's for 3 years.
3 years.
Actually, it starts with 6 months, and then you can extend it. I mean, you cannot extend it. It's a trial period of 6 months, and then if you manage to pass that, you can extend it up to three years.
And do you know what you might do? I know 3 years is obviously a long time, so it's almost as long as you've been studying as an undergraduate. Yeah. Do you have any sort of plans after that, or any sort of things that you're thinking of in the future that you might like to do?
After this period of 3 years, I am not sure, to be honest. I could, because once you finish that, you can also continue at CERN with, for example, a staff contract if you want to, and if you manage to get it. But I'm thinking that maybe I will find something that I'm very passionate about, like a specific kind of software technology. And who knows, maybe try to have a master or a PhD after. I'm not sure at the moment. Or just stay there and work ahead.
Carry on being an engineer without doing any further study. So I guess, there's lots of options there for the future. Yeah. It sounds good. So I've got two final questions, really. So one is, so that these interviews are aimed primarily at other students. So what advice would you give to students who are looking for either summer internships or placements during their first and second years of study? What would you advise them to do? What do you think they should be doing?
Yeah, I think I could talk a lot about that. So yeah, first, I think they should try to find companies or organizations that they identify with or they appreciate, because this way they will feel more dedicated to make a good application. And also, if they get accepted, they will feel they'll be happier to work for that specific company or organization. Then a lot of effort has to be put into the application. I know myself, because in the second year I realized there are a lot of talented students that want the same job. It's very important to be able to stand out with some personal touch of the application or in the CV. So putting a lot of effort in that is important. And then yeah, I think this is pretty much it.
Yeah, I think the point you're saying about personalization is very important, because I hear stories about the volume of applications that the more competitive schemes, and CERN's probably one of the more competitive ones, it's hundreds a day of applications. You have to remember that there's a human being on the end of that who has to somehow try and find the stuff that they're interested in.
Exactly.
And it's one of the easiest ways to do that is to go through ones and just avoid ones that just look like they're generic applications.
Yeah, exactly.
Go on, sorry.
I wanted to say that I have a third advice. Do not apply to only one company or organization. This is very risky. It's very important to be able to have a backup, or who knows, maybe that backup that you have will actually end up being the company you want to work for. You never know. Yeah.
So what was your backup? So I know because CERN's obviously quite an attractive employer. Yeah. Did you have any backups other than CERN? What there are other places you were thinking, well, if I can't get CERN, then I'll do this? What other places were you considering at the time?
Yes. I had two others. There were DataStax and Koderly.
Right.
So I got an offer from them, and I knew that I could go there in case I don't get into CERN. Yeah.
I think it's always tricky balancing quantity of applications with quality, because you can either do one or two really, really good high quality applications, but then if they get rejected, then you're stuck.
Yes, exactly. So not too many, but not only one, let's say.
And the other end of the scale is the sort of scattergun approach, where you just apply to,
Yeah. I don't know how much that works, but
not very often, I don't think. If you're doing lots of applications, then I've seen students do applications for 50, 60, 70 different internships or placements. And obviously, the more you start doing, the quality starts going down. So you've got to try and balance the quality with the quantity, and that's not always an easy thing to do.
Yeah. And then you also have to keep track of the 17 applications you made.
Yeah, yes. And remember what you said. Why was it I wanted to apply for that company? What is it?
Yeah,
What is it they do?
what they were doing. Exactly.
And I think that can obviously be bewildering as well, because I mean, how did you find balancing those commitments with managing a second year of study, but then also you need to have a social life as well, and balancing all these commitments can be quite hard sometimes, I think.
Yes, no, it was not easy, because second year it's busy with more things to do, more labs, and then you also want to apply for jobs, and you also want to have a social life. Exactly. So I try to organize my things pretty clear, to know what am I doing today or tomorrow. I usually make a list with what I have to do, and take let's say, for example, the weekend as free, or at least one day in the weekend is free. And but I was very passionate, and I really, really wanted to get a good placement. So I dedicated as much time as I could to that.
Yeah, and it's good. It's good to see that paid off in the end.
Yeah, thankfully.
Okay, so the other question I had was, so we talked about your plans for the future. So, what would you say are the most interesting thing or things happening in computer science or technology at the moment? Are there any things that you think this is a growing area? This is something that's going to be really, really interesting in the future.
Yeah, actually, this is I will answer it in a personal way. Neuromorphic computing that I talked about before, this is still a very interesting area for me, and because I worked on such a small part of it, I realized how big it is actually, this area of research. And I think that if in the future we will be able to build computer architectures to simulate the same flexibility as the human brain and speed, with less energy being consumed, then it will be great in the future. It could revolutionize the way that computers work. So I'm following this, and especially the Human Brain Project at the moment, to see what will happen in the future.
Yeah, and it's kind of there's a lot more to be done in that area, isn't there? And not just from the computer science side, but as I say, from the neuroscience side as well, in terms of understanding
And I think
how brains work.
People who work on it need to learn a lot. As I was saying, only building one neural model, it's a very hard job to do. But building entire computer architecture is just unbelievably hard, actually.
Yeah. Okay, so actually, is there any crossover there? So we've talked about physics and the CERN and the Large Hadron Collider, and then you've talked about neuromorphic computing, and they're two almost entirely separate fields. Are there any sort of interesting crossovers between the two? Are there any things that you think you might be able to apply from what you've learned in your final year project to physics?
Yeah, this could be, because as we know, there's a lot of data generated from the physics experiments at CERN. So we have around 1 billion collisions per second. So we always have to find ways to store and process that data very fast and very good, and also to stock it somewhere. So technologies such as neuromorphic computing and this kind of architectures could maybe be able in the future to process that information faster or better. Of course, now the link is not completely clear for me, but I believe there could be some way of using that knowledge to process the physics data generated.
Because I know a lot of the computational power of Spinnaker, this neuromorphic computer, has yet to be used. So you can build a very powerful computer, but then you need people to be able to understand how to operate and use the resources that such a machine provides. So that sounds very interesting. Okay, so I think I've covered all the ground I wanted to. It's interesting finding out a little bit more about what you've been doing during your time here. It was great to hear about your experiences of CERN and what you've got planned for the future. Is there anything else you'd like to add before we close off?
Nothing, just maybe good luck to the students that are about to be in a placement or find a job.
Yes, thank you. Okay, good. All right. Well, thank you for joining us, Raluca. Now, I always struggle. I'm never sure with the name Raluca. Do I emphasize the A or the U? Where do I put the stress? Is it Raluca or is it Raluca?
It's Raluca.
It's Raluca, right? Okay.
Yeah.
I've got it
doesn't
now.
really matter. It's fine.
Because there are several other students called Raluca, and I always struggle with getting the emphasis in the right place.
It's a difficult name for somebody who's not Romanian.
Yeah, and I don't think there's not a near equivalent. It's a sort of
no, I don't think so.
But thank you, Raluca, for joining us, and
thank you for inviting me.
Thank you for listening to Hearing Your Future, the Coding Your Future podcast. You can find out more about this episode and all the other episodes in the full transcripts published in the Coding Your Future guidebook at cdyf.me/hearing. That's Charlie Delta Yankee Foxtrot Mike Echo. I hope you found something useful to help you code your future today.